looked at graphs, just the basic sine graph and the basic sine and cos graph. And we talked about the sine and cos graphs having a period of 2 pi. They start and then they end at 0 and 2 pi, but that also makes sense because it's the rotation of a unit circle. We also talked about them having an amplitude of 1 because they max out at 1 and min out at 1, and half that distance is 1. And then we talked about the range being from -1 to 1, and we talked about the domain being XCR. That was yesterday. Now we're going to look at equations. So if we look here, amplitude and period of any sine or cosine function. So the amplitude we talked about yesterday, we could do max minus min divided by 2 if we were given a graph. So you do this if you have a graph. However, the amplitude is also related to the A value. This is not it's the A value when you look at the equation. So this here and this here, the A value or the vertical stretch we could talk about, those result in the amplitude, which makes sense. Your amplitude, everyone paying attention please, your amplitude is from -1 to 1. What's the only thing that can make it higher or lower? What transformation can make it pulled or squished? What? Yeah, the vertical stretch, right? The vertical stretch can make it taller or narrower. We agree? So actually the vertical stretch is your amplitude. Because if you have -1 and 1 is resulted, if your vertical stretch is 2, it's now going to be stretching it to 2 and -2, right? If your vertical stretch is 1/2, it's going to stretch it to 1/2 and -1/2. So your vertical stretch is your amplitude. So basically what you can do is your vertical stretch, not the reflection, because your amplitude is always positive. Your vertical stretch equals your amplitude. Or if you're in the form A sine B theta or A cos B theta, it's the absolute value of A. Which makes sense because the absolute value of A is your vertical stretch. Remember, if it's a negative A, like say we had y equals -2 sine x, your amplitude is what? What's the vertical stretch? 2. Or we could say this is my A value. So it's the absolute value of -2, which is 2. Because does a reflection, if your graph is periodic, does a reflection actually make it taller or narrower? No, it just makes the maxes flip to mins and the mins flip to maxes, correct? But it doesn't make it any taller or any shorter, right? So it's just the vertical stretch. The other thing to note is what can cause your graph to be from 0 to 2 pi or squish in or stretch further? Your horizontal stretch, correct? Your horizontal stretch is what's going to make it bigger or shorter. Okay? So I know that the original period is 2 pi, and if I multiply it by my horizontal stretch, I'll get the actual period. Why did I put horizontal? Why did I write it like that? Yeah. If I multiply by the horizontal stretch, I'll get the new period. Or if it was 360, and I multiplied it by the horizontal stretch, I would get the new period. Because if the horizontal stretch is 1/2, and my original is 360, my period is now going to be 180, right? If the horizontal stretch is 1/2, it shrinks it. If the horizontal stretch is 2, it'll double it. Or you can use dividing by b values, but that just gets all confusing. So I do it this way. So, what is my amplitude of A? It's 2. Someone said that. I heard you. You're correct. The period, I'm going to say it's in radians. They would have to specify. So the period is normally 2 pi. What am I going to multiply it by? What's my horizontal stretch? 1/3. Remember that if you have a 3 here, that's your b value, but your horizontal stretch always flips. So it's going to be times 1/3. So it's going to be 2 pi over 3. So what's the amplitude of this one? The amplitude's 1/2 because it's equal to my vertical stretch. And the period, if I said it was in degrees this time, it would be 360 degrees, and then I multiply by the horizontal stretch, which is what? 2. Always flips. Some people are like, when does it not flip? Never. It always flips. So it's 2. So it's going to actually be 720 degrees. So for now, I don't want you to do the circling column, this part here at all. I'm not going to do this part for now. We will do it after together. I want you to state the transformations. So vertical stretch by factor blah about the blah blah. And horizontal stretch by factor blah about the blah blah. Okay? And then I want the amplitude and the period of all of them. So I don't know why I skipped. There's like a 1 and then a 4. That's good. And then a 5. It seems I didn't want 2 and 3. So do those 3. Okay. This one has a vertical stretch by a factor of what? Yeah. About the x-axis. Make sure you have all of that. Okay, we're going to talk about something. Does the amplitude change when I take the graph and stretch it? Yep. So it says circle the following that have changed. So we're going to talk about the amplitude changes. Does the range change if I take it and I stretch it? Yep. Does the period change if I take it and just stretch it vertically? No, it'll still happen in 2 pi, correct? Because b is what affects it. Does the domain change?
No.
Nope. Do the x-intercepts change if I pull it up like this, but I don't shift it right or shift it left? Nope. Does the y-intercept change if I pull it up like this? I would take my y-intercept and I would shove it up or shove it down, right? So the y-intercept would change. Okay. The amplitude would be equal to 2, and the period, if we do in radians, would be 2 pi times no stretch, so 2 pi. We agree? We're going to add to this the range. So the range before, when we did it before, we said between -1 and 1, correct? This one's been pulled up by 2. So now what's it going to be between? -2 and 2. So we're going to do y such that -2 is less than or equal to y is less than or equal to 2 yer. In set notation, in interval notation, it would be -2 to 2, square brackets because it's equal to. And you always go low to high. Now this one has no vertical stretch, but it does have a horizontal stretch. By a factor of 1/3. So it's getting narrower, right? Well, it's repeating itself faster. About the y-axis. So if I take the graph and I squish it by 1/3, does that change my amplitude? Change how tall it goes or how low it goes? No, the amplitude's still 1. What about the range? Does it change the range? No, because the amplitude is the only thing that affects the range. What about the period? Yes, it's squishing it. What about the domain? Technically, no, because the domain is XER, right? So it's just, it repeats itself more in XER, but it doesn't make it any less XER. X-intercepts, does it change? Yeah, because it's squishing it. What about the y-intercept? No, only because if the y-intercept is at like 0, 2, if I take 0 and multiply it by 1/3, it's still 0, right? Because of mapping. Okay, that's my amplitude. 1. The period is 2 pi times 1/3, which is 2 pi over 3. Or, yeah, 360 degrees times 1/3, which is 120 degrees. What is my range? Because I'm going to add it. Y such that y, yeah, because the amplitude hasn't changed just that one. Okay. Now we have cos. This one has a cos. Does cos or sine change any of the deals? No, they still follow the same rules. Cos and sine do, correct? So this one has a horizontal stretch. By a factor of about the y-axis. Does my amplitude change? This one's being pulled further, but does it change the height? No. Does it change the range? Does it change the period? Yeah, I take a 2 pi and I like pull it to 4 pi, right? Domain? No. X-intercept? Yeah. Yes. Y-intercept? No. So my amplitude is 1, because that's my vertical stretch. It's of nothing. And the period is 2 pi times 2, which is 4 pi, or 720, so 360 times 2. And my range is going to be y such that -1 is less than or equal to y, less than or equal to 1, y n. So the period of a sine graph is what? 2 pi or 360 degrees. The period of a cos graph? The parameter b in the equation y equals f bx, where f of x equals sine x or cos x, results in a horizontal stretch. And the period being 2 pi times 1 over b, or 360 degrees times 1 over b. This means b gives the number of cycles in 360. Period can be found by dividing them, like that. Or I like doing the period as 360 degrees times the horizontal stretch, or 2 pi times the horizontal stretch. It just makes more sense. So try this one out. These ones out, sorry. These 4. Go. Amplitude, horizontal stretch, factor. You don't have to write out the horizontal stretch, just the factor. So like 2, a factor of 2, 7, 1, whatever it may be. And then the period in degrees or radians. So it should be quick because there's not a lot of words. What's the amplitude of 1? The vertical stretch, which is 3. What's the horizontal stretch of this one? 1 over 2. So the period in degrees is 360 times a half, which is 180 degrees, or pi. This one, you have an amplitude of 2, a horizontal stretch by a third. So you do 360 times a third, which is 120, or 2 pi times a third, which is 2 pi over 3. This one, what's my amplitude? 3, not -3, right? Because the amplitude is always positive, and it's the vertical stretch, not the reflection. And a horizontal stretch by a factor of 2. So the period is 360 times 2, so it's going to get larger, which makes sense. If you horizontally stretch by 2, you're taking 360 and you're making it 720. You're literally doubling it, right? And then 2 pi times 2 is 4 pi. This one, you have an amplitude of a half. Horizontal stretch by 4, which you're taking your period and multiplying it by 4. So it's 1440. And then 2 pi times 4. 8 pi. Here we're into the period and amplitude for each. So this one, the amplitude is 2. And the period is 360 times 1/3, so it's 120. This one, the amplitude is a half, and the period is 2 pi times 2, which is 4 pi. I'm going to flip over. Okay. we're going to talk about transformations and mapping. We're not going to sketch them. I don't really care for that right now, but we're just going to do some mapping. So what would my mapping be for this one? X, Y becomes, what happens to my X? It's multiplied by what? Nope. It's multiplied by 1/3. And what's my Y multiplied by? 2Y. Transformations. We have a vertical stretch. By a factor of 2 about the x-axis. And a horizontal stretch. By a factor of 1/3 about the y-axis. Not going to worry about the graphing for now. But how could I use mapping? I could put the basic sine graph on here, right? The one we did yesterday, 0, 0, and put that on. And then just put each of those coordinates into mapping and get my new points, right? We know how to do all of that by now. So that would be how you do this, okay? Flip over. This one I want mapping transformations, and I want domain and range. I'm not going to make you graph it, but I want mapping transformations, domain and range. If it wasn't a Friday, I'd make you graph it. Mapping is going to be x, y becomes 2x, because it always flips, 1/2 y. So I have a vertical stretch by a factor of 2 about x-axis and the horizontal stretch. Pardon? Up 2. It's true. Okay. What affects my amplitude? Vertical stretch. So it's half up, half down. Correct? Now the only way it can change your range, which is going to be on Monday, it's going to Tuesday. You're not here Monday. It'll affect your range because we'll move the graph up and down. So if we move the graph up to like 2, and then it had a vertical stretch by a factor of 1, we would now be at 3 and 1 for our range. So the range will change. We haven't transformed, we haven't shoved it up or down at all, right? There is no d value on here. There's no vertical translation. So that's why our ranges are easy, because they're just up the amplitude, down the amplitude, right? So the amplitude is a half right now. So my range is going to be y such that negative 1/2 is less than or equal to y is less than or equal to 1/2 y-yard. That will change once we get a vertical translation. My domain doesn't change, it's x here. Okay? So we'll move to the next page. So the next page I give you graphs, and I want the equation of the graph. So, A is my amplitude, correct? What is my amplitude on this graph? It's 3 because it's centered so nicely, correct? 3 up, 3 down, which is 6 total. Half of that is 3. We agree? So my A value is 3 sine. What's my B going to be? So it's from 0 to 180. We agree? So what happened to my graph? It got squished, correct? By half. So the horizontal stretch is by a half. We agree? So what's my B? 2. So this is a horizontal stretch of a half. So my B equals 2. What's the A of this one? Up 2, down 2. So this is 1, 2, 3, 4. A total distance of 4. So my amplitude is 2, because it's half the vertical distance, correct? So if this takes me 1, 2, 3, 4 to get to the top, my amplitude is 2. And this thing starts at 360, goes past a min, back up to a max. That's how long it takes to repeat itself, correct? 360 to 360 is how much? 720. So what did I horizontally stretch by? 2. So my equation is going to be y equals my amplitude, which is 2, cos. Now what? A half. Now there's a catch. This is all completely correct. Those numbers are correct. But what does a cos graph normally start at? 0, 1, correct? And then it goes like this, and then like this. So it actually normally starts on its maximum. The y-intercept is its maximum. What is the y-intercept this time? It's minimum, correct? So the graph did this. So it's a reflection in the x-axis. So my a should actually be -2. So your a value will always be the vertical stretch, we agree? But you have to look and see with cos graphs, is the maximum on the y or is the minimum for these? Yeah, but there's no c on here, so we can't use a horizontal translation. But yes. Talon was saying, well, can't we just say 360 and move to the right 360? Yes, you can, but there's no c, so they are making you do it into the actual a value of a reflection. Okay, next page. Now, sine graphs always go upwards like this. So if it's going downwards, then it would be negative. But this one's going up, so it's totally fine. What's my amplitude of this one? It's a half, because it's a half plus a half, which is 1. 1 divided by 2 is a half. So it's 0.5. And then the period of this graph. So if we start here, we go past a max, past a min, back up to that height. It's 2 pi. So how has it been stretched? Vertically, yeah. But there's no horizontal stretch on this one, is there? So what's my b going to be? 1. And my a is going to be 0.5. This is the sine graph. You don't really need the 1, but I put it anyways. Yeah. Yeah. We're going to make this one be a cos graph. What's my amplitude? 1. So it's going to be 1 cos. And it's positive 1 because the maximum is on, right? And we count from a max to a max. Wait a second, it's 2 pi over 3. 2 pi over 3. What's my horizontal stretch then? It's 1/3, correct? So what am I going to put in for my b? The homework is down here, but I'm not giving that much. And then you can, oops, I stripped my page. Then you can start working on this, because there's actually time. And I am going to come around and check your page 306. Number 4, I want you to do, but it says sketch. I don't want you to sketch. Okay? It just says determine the amplitude of each periodic function and then sketch it. I don't want you to sketch it. Number 5 says state the period and then sketch it. I don't want you to sketch it. Number 6 is a matching. I guess 4 to 9. 4 to 9. No sketching. If it says sketch, be like, no, not today. No sketching. A few of them say sketch. Just be like, I'll save you for that today. Won't make you do it.